Ladies and gentlemen, my name is Dr. Guntram Kugler. I am working for the German company Textechno. I have been asked to hold during the FICOTA meeting a lecture about setting up a cotton-based textile supply chain in Africa. I cannot come personally to Camneroon, therefore I have recorded my lecture with a headline: Roadmap to set up a cotton-based textile supply chain in Africa. The destination of the African Chamber of Commerce since several times is to develop a textile supply chain in Africa based on the local cotton industry. This is surely not a short process that needs more time, and it takes place in several steps. When we compare this applied development, we can say Uzbekistan is the best example to see what steps need to be done. The first step is cotton cultivation, harvesting, ginning and exporting of cotton. Uzbekistan was since many years one of the biggest exporter of cotton to all over the world. According to the government of Uzbekistan, they started 20 years ago to set up spinning mills in order to realize yarn production on base of the available cotton. And then these yarns have been exported. The third step is the establishment of weaving and knitting mills, and the Uzbek government decided to go this way approximately 5 years ago. Then they export own processing in ready-to-wear textile clothes. Of course, such a process requires education and training of local specialists for every development step with well-founded training courses. This long-term program gives to the African people, especially the young generation, good development chances. Let's have now a look to the necessary steps what have to be done. The first step is, of course, cultivation and harvesting of local produced cotton. In the seventh step, we have to set up modern ginning mills in order to separate the clean fibers from the impurities in the cotton. In connection with the ginning mills, we have, of course, the packing of the cotton in bales on the same location. The next step is to establish testing and classifying centers, then selling the cotton locally and exporting by created cotton sales organizations. The next step is the production of yarns in new to create spinning mills. The next step is production of woven and knitted fabrics on base of the own produced yarns in Africa. And finishing, dyeing and printing industry needs to be set up. And the last step is confection, fashion design, fashion and own processing in ready-to-wear clothes. Let's come to the first step, cultivation and harvesting of cotton. The cotton currently cultivated in Africa is not competitive. The color is too dark, the stable length is too short. If we have a look to the upper half mean length of the currently produced cotton in Africa, this is with 25 up to 26 millimeters, much too short in order to give a good yarn quality. That means we have to replace the existing cotton with cotton of higher quality, for example Pima cotton for ring spinning process and upland cotton for open end spinning. The cultivation on new local cotton fields needs support of the cotton farmers. Harvesting of the major cotton manually, this is a very important rule, because in that case we have less mechanical damages of the cotton fibers. We do not shorten the length. This is important. That process gives work to the local people who are living in that region. For farmers and workers, it is very important to get an agriculture education on local universities. The produced and harvested cotton needs to be separated from the impurities in order to get out the clean fibers. So that means the existing ginning mills in Africa are outdated with old machines. We have to set up new ginning mills with new ginning machines, and the favorite ginning machines are roller ginning machines, because on base of using the roller ginning machines, we can get the target achieving a good fiber quality with a good upper half mean length. We have also to realize short transportation routes between the cotton fields and the ginning mills. That means ginning mills needs to be very close to the location of the cotton fields. That saves costs and secures work for the local workers. After ginning, the fiber material needs to be packed into bales. The packing should be part of the ginning mills. It is important to establish testing and grading centers to determine the cotton quality, because the basis for the price determination for the sales of cotton is to evaluate the cotton quality. These centers need educated personnel to perform testing and grading. Education training should be done at local institutes and universities. The next step is, when we have the clean cotton packed in bales, we need to establish a sales organization for the cotton sales domestically in Africa and for exporting the cotton to the world. Important is that cotton sales is here to accumulate financial resources for further development steps for the textile supply chain in Africa. After the cotton industry is working well, we have to use the local produced cotton in own spinning mills. So that means we have to set up new rotor and ring spinning mills with new modern machines. As more spinning mills are established, the more the export of cotton is reduced, because the cotton is used in the domestic spinning mills. Locally manufactured spun yarns are initially exported, and for running the new spinning mills, of course, here is the same valid. We need educated and trained personnel. This is a task for the local universities. The next step of the supply chain is to establish weaving mills and knitting mills to produce fabrics themselves in Africa. Including with this is also exporting of ready fabrics. Mostly together with setting up weaving and knitting mills, the next step in the chain is done. Finishing and manufactured woven and knitted fabrics by dyeing and printing. This is preliminary stage for the final development step in cotton-based textile supply chain, step 9. The creation of an own African fashion industry consisting of fashion design. The African fashion industry needs to be strongly influenced by the African traditions and culture. Let's go now to the second step. Sales is necessary to accumulate financial resources. These are used for further developments of the textile supply chain in Africa. For the sales and the export, the quality of the cotton must be evaluated. On base of the quality, achievable price can be fixed. For the quality assessment of cotton, we have to use the recommendations of the USDA, that is the United States Department of Agriculture. These recommendations are accepted and well known worldwide. These characteristics of the cotton are used for the evaluation: micronear value and maturity level, fiber bundle strength and elongation, stable length code, and final grade, also called clusters grade. Let's discuss now how we are going to measure, how we are going to determine these parameters. For the determination of micronear and maturity values for the parameter A, we are measuring the cotton by using micronear and maturity airflow testing devices. USDA gives for the micronear and maturity following recommendation. So these both table, what you can see here on the left side, the recommendations of the quality for the micronear measured, and on the right side for the measured maturity. We have always defined a limit, below limit and upper limit, and when our cotton is within this range, then we have the quality definition on the right side. So for example, if we have a micronear value from 4 up to 4.9, we can say this is a medium fiber quality. For a maturity, for example, 0.95 up to 1 is an upper medium quality of the cotton. Let's go to the next. Fiber bundle strength and elongation, this is a parameter B, are measured on cotton using fiber bundle strength and length testing devices. Also here, USDA gives some recommendations according to these both quality tables. So if we have a strength from 18 up to 21 centinewton per tex, we have a weak. If we have above 30, we have a very strong cotton. For the elongation, it's the same. Below 5.0% of elongation, we have very low quality, and above 7.6, we have a high quality. The same we can see here for the so-called stable length code. This is a feature C. This stable length code is derived from the measured values of the upper half mean length for the tested cotton. On the left side, we can see the intervals for the upper half mean length ranges, and on the right side, we can see the definition for the stable length code. So for example, when we have a look to the current cotton here in Africa, we have 25.1 millimeter up to 25.7 millimeter. We have a fiber length code of 32. For the final or clusters grade feature D, these are derived from the measured values of whiteness, RD, yellowness plus B, thresh count and thresh area. The color values, that means plus B and RD, are very heavily influenced by the thresh parts, naps and seed coat naps. These are expressed in the thresh count and thresh area. The larger the thresh count and the thresh area, whiteness level RD is getting smaller, the final grade is worse. After measuring the whiteness degree and the yellowness degree plus B, the final clusters grade is read from the following diagram. So this is the color diagram. On the left side we have the whiteness degree. On the below side, the x-axis is the yellowness degree. And what you can see are here in this field is mentioned the so-called clusters or final grade. I have prepared an example. So the red line, what you can see here, describes one example. We have a final or clusters grade sample, red marked, with a whiteness degree of 75 here, and a yellowness degree of 7.8. The point where the lines are crossing each other is the area marked with the final or clusters grade 41. What this cluster or final grade means, we can see from the next table. So the cotton with the final clusters grade 41 is called strict low middling. This you can see here, strict low middling. and the symbol is SLM. The cotton price is calculated on base. The cotton prices are calculated on base of a price table what contains prices for different classes grade, for different micronear and maturity values, as well as stable length codes, strength, elongation, and so on. I have prepared two examples for giving an idea about the price calculation. So the first sample is a US cotton with following data. The micronear value is 4.1, the maturity value is 0.98, the strength bundle value is 25.6 centinewton per tex, elongation is 7.2, and the length code 38, and the final grade is 31. This means middling with the symbol MID. The price what we can achieve for this cotton in Europe is 100 US cent per lips. One bale has 218 kg. These are 480 lips. The price for the bale is 480 lips multiplied with 100 US dollar. That means for one bale we can get 480 US dollar. Now we compare it with the second sample. The micronear value and maturity, as well as strength and elongation and length code, is the same. So the difference is only in the final grade. So we have a final grade here with 51. This means low middling. And for this low middling cotton in Europe, we can get only 97 US cent per lips. Same calculation, one bale has 218 kg, 480 lbs, lips. The price is 480 lips multiplied with 97 US cent. That means we can get for this bale 465 US dollar. So the difference is 15 US dollar. In case of 100 bales, we have already a price difference of $150. That means higher quality means always better price. Let's come now to the testing devices to measure this quality characteristics of cotton. So usually for this, HVI testing devices are used to test the quality determining characteristics of cotton. HVI stands here for high volume instruments. High volume instrument consists of modules. The first module is for determining the micronear and maturity, then for the bundle strength and elongation, as well as staple length, upper half mean length. Then one module is for testing the whiteness and yellowness degree, thresh count, and thresh area. The most commonly used system is the Uster HVI 1000. This system allows a high test throughput, but is very vulnerable under African climatic conditions. For example, high temperatures and high humidity variations leads to electronic components often fail. Another disadvantage, HVI system must work under constant laboratory climate. Otherwise, errors occur again and again when you try to calibrate the system with required calibration cotton. Unstable power supply affects operation as well. The software crashes down and data get lost. An alternative system is produced by our company Textechno. We call this system Fiber Classifying System FCS. FCS system has a lower test throughput compared to the HVI 1000, but has advantages that makes the system suitable for the African market. Here on the picture you can see a Textechno Fiber Classifying System version 5.5. Here you can see for the fiber cotton classifying system these individual modules. We have the fiber test module, what you can see here. This is a fiber length and fiber bundle strength testing device. what measures the absolute and HVI results. We have the opto test for thresh analyzing and color classification. We have the fiber flow, what measures micronair and maturity according to the double compression method. And the MTDA4, what realizes a thresh separation from the clean fibers and a sliver creation. When we have a look to this fiber classifying system, we can say that this is a complete new generation of testers suitable for testing all important fiber materials. For example, short and long stable natural fibers like cotton wool, cashmere linen, etc. Short and long stable man-made fibers, polyester, viscose modal, viscose tencel, acryl, aramid, etc. And extremely short fibers, recycling fibers, kapok, etc. So the HVI 1000 measures only cotton. So the next feature is this system consists of the station's fiber test for fiber length, fiber bundle strength measurement, opto test for whiteness, yellowness, thresh count, thresh area, fiber flow station, what measures micronair and maturity value as well as linear density, and the MTDA4 station, what measures impurities. All these testing devices are connected to a central computer PC. So this system is very flexible. The user can specify his own system configuration. The stations are working independent on each other. The sample form can be slivers from the bales, carding and draw frame slivers, and flyer rovings. The system is comparable with an HVI system and allows to realize two different test modi. The first one is the HVI, like HVI testers are doing, and the second one is a direct testing method, what is especially used for other fibers than cotton. We have still some more special advantages. The system is very robust against changes of climatic conditions in the laboratory due to absolute measuring of all parameters. The high stability of calibration is superb. Calibration with HVI calibration requires only once per week and not like HVI 1000 every day. The system is also very robust against power supply variations due to the modular concept. In case one station is damaged, all other stations can still be used. Here again, a short introduction of the complete system. Let me explain you something more about the MTDA4. With the MTDA4, we separate the clean fibers from the impurity. For that purpose, we put on the belt on the right side the fiber material. The fiber material runs through the testing device and creates a ring of clean fibers. And in 3 drawers, we collect rough, coarse impurities such like naps, seed coat naps, and trash parts. We collect in 1 drawer, the upper drawer on the right side, the fiber fragments, that means broken fibers during the processing, and the dust. Now let's come to the fiber test. The fiber test has one big advantage. We show 1, 2, 3, 4 graphs. Here on the right side, you have the graph for the all fibrograms in. You have a picture of the sample. You have the force elongation curves, and you have for one test all the curves like fibrogram and stable length curve and also histogram. Here you can see that we have for the fiber length distribution a lot of parameters: upper half mean length, upper quartile length, stable length, span length 50%, stable length 25%, and up to the absolute strength. And on the right side we have this 3 parameter for the calibration cotton. That means relative upper half mean length, HVI upper half mean length, HVI uniformity index, and HVI strength. So let's come to the opto test. The opto test is a measuring device what measures the whiteness and yellowness degree, RD and plus B, thresh count and thresh area, and from this parameters, thresh count and thresh area, we calculate the leaf grade CG. And in addition, we also measure the C-Lab color values L, A, and B, and in combination with the MTTA4, we can also measure the naps per gram, seed coat naps per gram, and thresh parts per gram. I already explained that we collect in the big chamber the coarse impurities, such like naps, what do have the white color, then the thresh parts, what do have the dark color, and the seed coat naps. Then we are using an image processing software in order to find out the different impurities, and you can see here the naps are colored in green, the thresh parts are colored in blue, and the seed coat naps are in orange. The next testing station is the fibroflow, and the fibroflow measures the micronear value according to ISO 2403 or ASTM D1448. It measures the maturity according to ISO 10306, and we have a display and PC interface, and at least the calculated parameters are micronear value, maturity value, percent of mature fibers, and linear density in millitex. Here you can see a printout for all testing stations, and you can see here the red marked columns are the same test results like in HVI 1000. The blue marked columns are coming from the Uster AFIS, what is one additional system. And you can also see below the evaluation of the tested results according to USDA recommendations. So for example, micronear value medium, maturity value high, upper half mean length long, fiber length code 36, uniformity index medium, strong is strength and elongation very high, and the known lint count comes from the MTTA4. The known lint count is trashy. So here you can see that with our Textechno fiber classifying system, you can test practically all necessary parameters in order to describe the quality of the cotton. In case of Uster, you need 2 testing devices in order to get the same test results how we are getting with one system.